Hello and welcome to this episode. In this video, I'm going to explain to you the paradigm shift between traditional software engineering approach and then the machine learning approach to solving problems. So when you see SE, what I'm talking about is software engineering. And the reason why this lecture or this video is important is that once you begin to work in the domain of machine learning or deep learning or AI, you need a change of mindset, you need a change of approach, and that is what is known as the paradigm shift. What you are used to doing in traditional software engineering is quite different from what you are used to doing in the machine learning approach to solving problems. So in traditional software engineering, if you have a problem and then you want to write a program to solve that problem, what happens is that you need to know the rules that leads to the solution of the problem. So if I want to write a program to solve quadratic equation, for example, I know that the root of a quadratic equation is going to be minus b plus or minus b squared minus 2ac over blah 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 blah. Okay, now once I know this formula becomes the rules of the program. Okay, this formula becomes the rules of the program. And what you have to do as a software engineer is to be able to translate this formula into a program. So that is your rules, and then you are able to give it an input, and based on the rules, the input will be run through the rules and it's going to produce an output for you. That is a normal way we do things. It is the same approach we use over and over and over in traditional software engineering. If I take this example away and I bring a new example, let's say you're writing a program to calculate how much taxes people are supposed to pay at the end of the month. The first thing you need to know is what rules governs the calculation of taxes. Things that are important or things that might be important are the city of residence, because different cities have different tax rules or tax rates, the age of the person, whether the person is married or not, whether the person have kids, and sometimes there are some initial non-taxable amount in your salary, and of course how much money the person is taking at the end of the month. Now these become your rules, like knowing the tax rate of the city, how much of your salary, how much of your monthly salary is non-taxable, and then how much you gain in taxes if you have children, how much you gain in taxes if you are married. These are all the rules. And then the input is going to be the monthly salary of the person. Now, once you enter the monthly salary, the salary is going to be run through the rules that you have turned into the program source code, and it's going to generate an output for you to be able to know that, okay, for this particular set of input or this particular monthly salary with these conditions, this is how much tax is supposed to be paid at the end of the month. Now, the interesting thing that happens when you begin to use a machine learning approach is that things are swapped around a bit. So you can see that we have input, rules, and output, but over here we have input, output, and then rules. Okay, now when it comes to the machine learning approach, you need a large set of data, and this large data set is usually a large labeled data set. So large labeled data set, and by labeled, what I mean is that you have your training data, you gather a lot of data, and then you will manually label them. So let me give an example to make it concrete. Let's say I am trying to build a model to distinguish between cats and dogs. The approach is that I will have to gather tens and thousands of images of cats and dogs on different backgrounds. I mean, when you are taking the picture, you need to make sure that the cats are in varied backgrounds, performing varied actions, and also some must be in obscured environment. Some might have some of their body part not showing entirely. The whole idea here is to capture the variety in the settings in which you can find cats and dogs. Once you have these thousands of images of cats and dogs, you sit down and then you manually label them. So you say, okay, picture 1 is a cat, picture 2 is a dog, picture 3 is a cat, picture 4 is a cat, picture 5 is a dog, picture 6 is a dog. You do all these things, and so your input data is going to be something like this. Your data set is going to look something like this. So the columns or the things that define your data set, if it is a tabular data, is going to look something like this. So you have your label here, and then these are features of your data. So for images, let's say I have a 1, 2, 3, 4, 5. Let's say I have an image that is made up of just 5 pixels, just for an example. So for pixel 1, pixel 2, pixel 3, pixel 4, pixel 5. And then you enter all these here. So these are going to be values here, which are usually numbers. And then your labels, you have to say, okay, this is a cat, this is a dog, this is a cat, this is a cat, this is a dog. Of course, you are not going to use these textual representations. They are usually turned into numbers. But the whole idea is that you will first of all gather the data, and then you will label them. And once you have labeled them, you will give the input. So everything here is going to be the input, and everything here is going to be the expected output. Now, you feed these two, your input and expected output, into your model, and then the model is supposed to learn rules, internal rules, that will help it to map a given input to a given output. So by the time you finish training, it is expected that when you show the model a never seen before data in this class or in these categories, the model is supposed to be able to tell you, this is a cat, this is a dog, and at a satisfactory level of accuracy. Okay, so you gather a lot of data, and then once you run through this repeatedly, and of course, we will understand all these things in future videos. I am taking my time to explain all these things to you because they are very, very important concepts that you need to understand, so that once we start getting hands-on, things will not be difficult for you to grasp. Okay, so you gather this data, you run it through the model repeatedly, and on every repetition, the model is going to make some adjustments in its internal representation, such that by the time you say you are done with training, your model will accurately be able to predict all input in the training data set and satisfactorily predict correct output for never seen data that are similar to what you used to train it over here. Now, the difference in the approach when it comes to ML and deep learning is that in traditional machine learning, we have specific algorithms like decision trees, decision trees. We have XGBoost. We have regressors, and then for regressors we can have logistic regression and then linear regression. We have a lot of very specific algorithms for specific problem types. Okay, we also have things like principal component analysis, which helps us to reduce the dimensionality of our data sets, and then we also have t-SNE. These two are a different approach to machine learning, which is called unsupervised learning, and I will also explain this in an upcoming video. In traditional machine learning, we have all these different algorithms that can be used to map a given input to an output. But when it comes to deep learning, the beauty of deep learning is that for anything you do, you rely exclusively on a neural network. Okay? And so deep learning makes use of neural networks to learn mappings between input and output. And it is for this reason that neural networks are called universal function approximators. Universal function approximators. So, given an ample size of data set and a number of training times, it is proven that a neural network will be able to approximate any function at all. So, over here, if you are doing traditional machine learning, then the model can be any of these algorithms. But if you are doing deep learning, then it is almost always going to be the case that you are using neural networks over here to automatically learn these rules. So thank you very much for watching, and I'll see you in the next video.